Hello class 10th. Now in this series we are going to study combination of resistance. Already we have studied about the resistors. I have told you what is a resistor. Resistor is a component which gives obstruction to the current or hindrance to the current, means it is blocking the path of the current to move through the wire. That is what we call as resistance. And how the resistance is produced? We know that there are freely moving electrons which are moving through the conductor or the conducting wire. So when they are colliding with the ions or the atom present in their way, they are providing the hindrance to the flow of the current. So this is what we call as resistance. The unit of resistance is ohm. We have discussed about the resistivity also. What is resistivity? We know that the formula of resistance is R equals to rho L upon A. When the length and area is 1 unit, then the resistance is equals to resistivity. Or we say that the resistance of a unit length and unit cross section area of any conductor is called as its resistivity. And resistivity is dependent upon what? It is dependent upon the material of the body. Resistance depends upon the length, breadth, length and area as well as on the material of the body. So now here we will be studying about the combination of the resistors. Resistors can be combined in two ways. One is series and the other is parallel. In series, if we are combining the resistance, then the resistance of the circuit increases. But if we combine the resistors in parallel, then the resistance decreases. So let us start with this. So now coming to combination of resistors. The resistors can be combined in two ways. One is a series and other is a parallel combination. So let us see. In series, as I told you, the resistance will increase, and in parallel the resistance is going to decrease. Now if I connect the resistors N to N like this type of combination of resistors will be called as a series resistance. Let this be the R1 and this be R2. And if I connect the resistors in this form, one end of the very first end of the two resistors to one terminal and the last end of the resistors to the other terminal, this type of combination will be called as the parallel combination. So first we are going to study about the series combination. Now let us see. If I take, suppose say any three resistors R1, R2, R3. Let this be R1, this be R2 and this be R3, and connect this to a cell of potential V volts such that I current flows through the circuit. Okay, so this is the circuit what I have made. I have taken three resistors R1, R2 and R3 connected to a source of EMF, that is a cell, which is giving a voltage of V volt. I current flows through the circuit. Now this combination is in series. In series, the current flowing through all the resistors will be same. There will be no breakup of the current over here. Same current is going to flow through it and I current will be received at the end. But the potential, that is voltage, will be divided. In the first segment it will be V1 volts, suppose. In the second it is V2 and in the third it is V3. So the voltage will be V1, V2, V3 respectively through the three resistors. Now instead of this, if I replace all the three resistors with the equivalent resistance such that it withdraws the same current I through the cell. Okay, I am considering one more circuit such that if I put a resistor with the same battery of V volt, let this to be R, and I current is withdrawn by this, then this resistance will be called as the equivalent resistance for this. Means what the work the combination of these three resistors are doing, the same work this single resistor is also doing. So let us see now the formula or the derivation for the resistors in series. See, we have a derivation over here. Now in this case, in this circuit, V volt is being divided into V1 plus V2 plus V3. That is the voltage across these three resistors. Let this equation be the first equation. Now according to Ohm's law, we know that V equals to IR. V equals to IR, that is voltage equals to current into resistance. So according to this, the resistance of the very first resistor R1, okay, the voltage of the very first R1 resistance will be given as V1 equals to I R1. As the same current flows in all the resistors, so we are not going to take the value of the current to be changed. V1 equals to I R1. In the second one we have V2 equals to I R2, and in the third one we have V3 equals to I R3. Now if I substitute all the three, V1, V2, V3, the value of all the three in the first equation, that is V, I will be having, see, according to Ohm's law, if I have, you write it like this. According to Ohm's law, if you have the value of V, I, R, and V1 equals to I, R1, V2 equals to I, R2, and V3 equals to I, R3. Taking I as common and cancelling it out, see, I, R equals to I, in bracket I am taking R1 plus R2 plus R3. So cancel out I from both the sides. We will be left with R equals to R1 plus R2 plus R3. So this is the formula of equivalent resistance in series. If you have any number of resistors connected in series, say R1, R2, R3, R4, R5 and so on up till N, then the total or equivalent resistance of all the resistors will be equal to the algebraic sum of those individual resistances. Okay, so over here we can prove this R1, R2, R3. If we are combining all the three resistances, then the equivalent resistance will be R over here. See, which draws the same current from the battery. Now if suppose the value of the resistors, I am taking, suppose the value of these resistors R1, R2, R3, we say R1 is 10 ohm, R2 is 20 ohms, and R3 is say 40 ohms. Then in that case, R, the equivalent resistance of all three resistors, will be equal to the sum total of the individual resistances, that is 10 plus 20 plus 40. So 40 plus 2, 60, 60 plus 10, 70. So 70 ohm will be the answer of all the resistance. Okay, now if we consider other, suppose say any number of resistance, suppose if I am saying 5 resistances of each of 10 ohms are connected in series. So 5 resistances all are of same value. R1, R2, R3, R4 and R5, and all are of equivalent resistance, that is equal resistance, that is equals to 10 ohm. So what will be the value of resistance? Simply 5 multiplied by R, that is 5 into 10, 50 ohm. If the same number, if n number of resistors are connected, you can have n into R. Okay, you have over here 5 resistors connected, 4 resistors connected over here, sorry, 5 resistors connected over here. So the value is 50 ohm. Instead of 5, if you have n number of resistors having same resistance connected, then same value of resistance, then the value of resistance will be equals to n into R. Now in the next segment we will be coming up with the parallel combination of the resistances.